Welcome, this is a recorded session of the Post-Quantum Cryptography Conference of the PKI Consortium. This conference would not have been possible without our sponsors, PQ Shield, SSL.com, Entrust, Keyfactor, HID Global, and the organizational support of the Post-Quantum Cryptography Working Group of the PKI Consortium, and in particular, Entrust, Keyfactor, and Logius. Would you like to join the PKI Consortium? Go to pkic.org/join, or contact us if you would like to become a sponsor.
All right, so we are wrapping up our breakout presentations today, securing data in the quantum era from the root of trust to protecting ecosystems. So I'm happy to introduce Niels Gerhardt, Chief Technology Officer at Utimaco. Over to you.
Thank you. So apparently I'm the last presenter for today, and you probably have heard of a lot of around PQC over the last 2 days. So now it's my job to make this an exciting one and still share some new things with you. So nice, Bruno. I was seeing the end of your talk. That's great. So I don't have to repeat some of those things. But of course, I will also talk a little bit about HSMs. But it will actually also address other products. Sure, I will move back a little bit into the center of the camera so they can see me online as well. So the talk, when we thought, okay, what are we putting together? We were thinking, okay, there are certain things that are already solved on the HSM side in terms of PQC and supporting some of the migration topics. But there are also still some open topics that the industry is working on and that should help going forward of the adoption of post-quantum cryptography. So that's the first thing. So HSMs are somewhat the building block and a good starting point, as I mentioned before in the panel, to explore and to use the algorithms that are already there. But then again, we also we use in all the setups different, I call them security solutions, right? It could be a PKI system. I'm just included it because it's the PKI conference here. You probably know a lot about this, so you won't learn too much in that part. But if it goes down and we talk about key management and then the persistence of data and encryption of data, that actually becomes more interesting, I believe, and what you need to do to actually make those systems quantum safe. And then finally, and I think this is something that we all have to realize, this is a journey that will take a couple of years. So we are also involved in some projects that are research projects, that are at a research stage, and that actually look at how these some of these protocols that you see in the financial world will be transitioning into a PQ-safe world. And that's just something where I would like to make you aware of this project, and it's in the starting phase, but perhaps that is something to watch and see what we learned from that. So but let's see where we are on the HSM side. I mean, what gave us whole as an industry a lot of push was the CNSA 2.0. It was the outline of algorithms you could use for different use cases. There was a clear timeline set, and I mean this helped pushing the whole topic. It was the first start where we saw the round 3 algorithms being used by our customers, including in production. There are customers that do very different things with that. So some protect the control plane of satellites, others do firmware signing, yet others do encryption, but that's more the rare case. It's more like firmware signing is the big one that started. And then with the hardware security modules were for them an entry point into using that, because they had a defined interface. They used these things from before. They were familiar with the interfaces, PKCs 11 and things like that. And so for them it was a good starting point. Plus also there is an abstraction layer, so there are simulators available that you can just freely download and try for yourself, and the development teams can basically spread this around and start using it, start playing around with these algorithms. Now then the standards came, and that was yet another push. There was no excuse anymore. Some were saying earlier, we don't have a standard yet, so we will just wait until something comes out. Now these standards are out, and that is actually the next push for all these algorithms that we have in place. What we should not forget is, and that's the small thing that it will evolve over time, we'll have still some algorithms that will need to be standardized and some algorithms that perhaps are a little bit more promoted in some jurisdictions, not so much in others, like Frodo, for instance. So there will be more algorithms that will be added to the HSMs, and that you will be able to use. But that's as much as I want to talk about the algorithms. I think that's a thing that we somewhat control and can provide to the industry in terms of a good tool to use into the world of PQC. But let me share a couple of more thoughts of what is next in our belief. The next thing would be hardware acceleration. So we actually today focus primarily on providing this in software, and the modern hardware that we have is capable of providing a performance level that most of the use cases you see today can be covered. But going forward, of course, with cloudification and everything, there will be the need for performance. And we did actually do some first implementations ourselves to see how that works. And I just wanted to share some of the more generic findings. So if you actually look into these implementations, they behave from a resource utilization similar to what we have as algorithms today. One of the challenges you face is you only have one FPGA, and that space now has to be sort of split up into traditional and potentially PQ algorithms. So you kind of share that space, but that's a different topic. Now the interesting thing here is the scalability, and then potentially also adding an extra layer of security. An HSM, as Bruno was saying, is a kind of self-contained device and provides a lot of the security in itself. Side channel attacks is part of our analysis. Like if we go to a lab, if we do a certification, that is something that is automatically part of the assessment. So that also applies to the software part. But of course, in hardware, you can do further things in your implementation to obfuscate some of the implementations. So that is another thing that we looked at. So that is actually one of the things that is coming. Another thing is the certification itself. So all these algorithms will be part of the certification itself, and that is another thing that you will see evolve. Now, another topic that we promoted for some time and we looked at was how can we actually make these algorithms, specifically the stateful hash-based algorithms, available to the industry in a straightforward way, so they behave almost like a stateless algorithm, and that is something that we also worked at, like LMS or XMSS as an example. And we proposed a way of doing that. So if you are in a distributed environment and you deploy HSMs and you're relying on the security of this HSM and the HSM as a sort of root of trust, then you can actually share all these keys and ensure that these keys are only used once in this trust relationship that you have that is set up between the HSMs. And that is something that we believe is something we will see more being used. So there are some refinements done on how this could be done, and so that the application really doesn't see any difference if that is now a stateless or a stateful algorithm, but using all the good properties of the security of hash-based algorithms going forward. So that's another thing that we believe is going to come and we'll see more so in the future. But let's change gear a little bit and talk about the security systems. And I didn't have a better name. I mean, perhaps someone has a better name here later on. But for me, I basically said I would talk about PKI, key management a little bit, and file and folder encryption. And really the first one, you probably know a lot about that, but our customers come to us and say we have a lot of different certificates, and also we as a consumer, we are using PKI, of course, ourselves. We have different types of certificates we need to support. We have the standard components, certification authority, registration, validation authority, and we have to find a way to actually make that quantum safe. Now, there are two major aspects. Perhaps you can say there are three. So first, it's about the certificates that are supported, be it traditional ones next to PQ certificates, to composite certificates. So this is the first thing that, of course, needs to be ensured. The second one is that you also support hybrid certificates. Hybrid is a good step, a good segue into the new world. Hybrid in a way that you can also talk to devices potentially that today use traditional means of cryptography, and just tomorrow speak PQC. And then, of course, the systems themselves have to be PQ safe. Somehow you need to authenticate towards the systems. The systems need to be able to verify the certificates, and so on and so on. So there's these two aspects that need to be solved for the PKI systems. And of course, I mean, X509 as a standard is probably the one way to go. So if you look at again how this could work from a process perspective, I mean, the first part that we look at is, okay, how much does the system itself follow the standard, just to make sure that we are compliant. Secondly, as a recommendation more for those that are not HSM vendors, I mean, we always start, of course, with the HSM that we provide, but here in this case, it's a good starting point to use the algorithms, get that in place, and then after that, use your PKI system. The migration to pure PQC certificates will of course take time, so hybrid is a good segue into that. What we need to ensure, of course, is for these systems that they can handle the larger key sizes and signature sizes. But I guess that's something that works. And then if it comes to pure PQC certificates, it's about the X509 standard that we see predominantly today. So let's change a little bit gears and talk about key management. The key management systems support, to some extent, PQC today, but there's also things that evolve in key management and still is evolving in key management. We look at key management as two different use cases, two different scenarios. One is the key injection that gives, for instance, a device in manufacturing, a chip, for instance, an identity. So that is one area that is important. That device has an identity later on to actually receive secure firmware updates, for instance, to authenticate to a network or do other things in a secure way. And then we have these enterprise use cases that all of you in the room, me included, are using on a regular basis, be it VPN or databases that are encrypted or other things that actually need key management and the protection of key management. So key management in general, you probably all know that, is about securely generating keys, storing keys, and managing the life cycle. That's the important thing. So automating as much as possible of the life cycle of keys. And that's also where the interesting aspect now comes into how do you migrate from the more traditional keys that you have into the quantum world, into the post-quantum cryptography world, and how do you actually support these keys inside of your key management solution. A lot of the key management solutions that are available are coming with HSM support, because that is a good storage for the keys that are being used. And if you look at what is important here, starting with the key injection side of things, you have a lot of devices, and there are more and more devices added to most companies today. So you have the volume of these connected digital endpoints that are essentially increasing, and you get basically more and more keys that you actually have to manage inside of the key management systems. And then, of course, you need to look into how do you replace keys, and how do you actually introduce PQC. So for that, you need to support the key sizes. You need to have the storage requirements for that, and of course, performance plays a role as well in the key management. And then on the enterprise side, and you saw this already on the first slide, this is also about discovering keys. That's not such an easy task, to be honest, because you can have crypto assets in a lot of distributed parts of the organization, but it's important that you actually have a way to discover that. That's not normally part of the key management itself, but it's a step that happens before the key management. But after that, the crypto assets that you actually discovered could be actually managed from this single pane of glass from your key management system that is allowing you to control all these keys. And going towards a more policy-driven cryptography, that's what we believe where the industry is going towards. So basically, good understanding of where you are today, what assets you have, where you want to be tomorrow, and then finding ways to manage that using policies in your enterprise. So that is on the key management side. So just to recap a little bit, we have the key injection use case, which is quite different from the enterprise one. You give the device an identity, and that device, of course, in the future will support PQC as well. And then, of course, you have the enterprise lifecycle management or key lifecycle management that you support that has not necessarily anything to do with devices, but could be also an identity of a user, for instance. And that is something that will also scale, because you will have to replace all the keys that you have today and add some post-quantum safe keys in the future. So those are the things that we see with key management, and I would be very interesting to get also your feedback a little bit on where you see these systems are. I can tell you from what we see in the market, some of the functions are already available, and these systems support PQC, but some others also need to catch up, because I mean, we had so many other things to fix first as an industry that key management was not in the immediate focus, but that is definitely something that we will see coming in the next month. And then something that may be a bit newer to this discussion here, it's about persisting data and making sure that the data is transparently encrypted. We have solutions today also that's partly used on the government side for protecting sensitive information. It doesn't really matter in where this is stored. It could be local on your PC, on your laptop, or it could be in the cloud. But if you look at what requirements you have, it's interesting to look into the key hierarchies, and I'm coming to that on the next slide. So this is actually a tool to make yourself compliant. So we have customers that have compliance requirements, for instance, to encrypt everything or everything of a specific category. Could be, okay, they encrypt all the Word files, or they encrypt everything in a specific path of the file system, right? This could be the rules around the system to provide protection for a specific type of data. And so if you look at how this is being done, at the file level, you have already today symmetric cryptography, so you don't need to do much here. That is how every file is encrypted and then decrypted. There are rules on top of that. So, for instance, a rule, like I said before, could be encrypt all the Word files, or encrypt all specific type of files in a specific part of the file system. This is a pretty flexible and pretty powerful thing, so you don't have to encrypt everything, but as soon as you actually take one of these rules, which is set by the security administrator, then the data is automatically encrypted. And these CAC that you see here as a key encryption key for the rule, that is also symmetric key. So that's also something that we don't need to immediately worry about, because that is quantum safe. Now, these rules, you can have different ones, and again, I said it's very flexible, so you have different rules at a fine granular level, you combine them into a profile, and this profile is something that you would need for a specific user, in a specific role, in a specific function on a device, for instance, and if you look at that profile itself still is a symmetric key, and that is also already quantum safe. However, now to unlock this profile and to use that is actually done and secured by asymmetric cryptography, and as you can guess, RSA today. And so that is something that we need to look at on how we actually bring this into the quantum safe space. And this is only for the user. There is yet another key that you don't see here on this graph here, on this hierarchy. There is another one that protects the integrity of these profiles, so you don't want these profiles to be changed in any way. That is actually an administrator key, and it's also an asymmetric key pair. And again, that is something that would need to be changed in the quantum secure world. So this is how you could actually set this up for securing your data. The good thing is, the good message here is, you only have to touch 2 parts of the system. You don't need to go through everything. And there's even a possibility for re-encrypting the whole content in a fairly straightforward way, or making this PQ safe by just adding this at the level of the user, what you see here, RSA and per user, and then also at the administrator side, and then you actually have that system secure. So, but let's look a little bit more into the details here, because I just showed you the hierarchies, but not how this is used. So an end user could have this asymmetric pair, the private key on a smart card, for example. It doesn't have to be one, but could be a smart card, for instance, to actually unlock this encryption profile. Remember, the encryption profile had all the different rules inside, and these rules were basically instructing the system, Windows, Linux, whatever you're using, to encrypt certain files or according to a certain rule. And then basically every single file would be encrypted using a symmetric key. Of course, you would be prone to store now, decrypt later attacks. So that is definitely something we want to touch rather soon, to make sure that the data that we store here is also secure at a time in, let's say, 10 years or 15 years, when quantum computers may be able to break today's cryptography. So this is actually the keys and how they're used in this file encryption way. So here again, you see how the HSM ties in. I told you that the HSM is a nice building block for PQC, and that is related to all the PKI key management as well as file and folder encryption. So you can use the HSM to have this PQC enabling done, and then actually you can import the certificates, and the security officer would then deploy that to all of the clients that you have, and the clients and the user would then be able to transparently encrypt all the data on the laptop. So we see actually R&D organizations using that. We have governments using that. So everyone that is conscious about the data and where it's stored and how it is protected. So that is something that then in the next step will also be made quantum safe. And then we have actually a little bit the view on the ecosystem. All these security systems will be next, but there are things that we see in the industry, like the payment industry, for instance, that really hasn't been touched for a long time, and it's using asymmetric cryptography and at different points. And we have a good example for that. There's a research project. There's companies here like ours that are commercial companies, but there are also research universities involved, and what I would call like the Bundesdruckerei. It's somewhat a private but company, right? A private public company, you could say. It's a mix of both. And they all get together to look at the IBIX protocol. It's a protocol where some of the corporates are connected to the banks, and then also some banks are connected among banks, among other banks. And the interesting thing here is you have a lot of aspects of cryptography built in. So you have some payment instructions. These payment instructions are signed, and then based on that, you also have a specific signature for the authentication. Then you go to the application level where you find encryption, and then finally you go to the TLS and the transport layer level, and that's something that you also need to look at. So it's really a complex thing, because it also is used for interoperability, and that will take a couple of years to fix and to come to a point to see where we actually have to touch this, and make a recommendation how PQC could be introduced into this IBIX protocol for the banking exchange. So it's something where we also involve quite heavily in the research part, because we believe that PQC is actually a project for the next years to come, because there's a lot of these systems. You will have the same discussion on the telco side, you will have the same discussions on the blockchain side. How do you actually make this all PQ safe? And so it's a good place to be honest, and then to see how we could fix that and making this a secure thing going forward. So here you see a couple of more details. We look at the key agreement, key encapsulation, of course. There are some symmetric cryptography used as well. So it's like all the stuff you have heard of the last 2 days, so I don't need to recap that, but the good thing is about this protocol and this banking space that you use all of that. And we are currently, the project is in the assess stage, so hopefully in a year from now or so, I can actually give an update and perhaps have the first recommendations and the first overview on what algorithms and what recommendations we have for the different parts to change and bringing this into the PQ safe space. So let me wrap up and then have some time for questions. So first, HSMs are a good building block for PQC. What we also see is that they're in commercial use. So we are quite far ahead with HSMs as such, and there is some trust there that the PQC that they provide is a good starting point, also really for productive setups of customers in very different areas. Secondly, there's still room for improvement, and there are actually things being developed. So it's, I'd say, partly commercial, but there's also things that still need to be commercialized on these security systems. It doesn't matter whether you look at PKI, key management, or file and folder encryption. It is just a little bit of a more long-term play when these systems have to be fully PQ ready. And that is actually what we currently see. And then finally, we have these what I call like big problems, the challenges that we face in really full ecosystems where a lot of partners are interacting and working together using things like EBICs, for example. And these ecosystems need to migrate to PQ safe state. And that will take a couple of years until that actually happens. And that's actually something that we also want to support all the time. And that brings me to the Q&A.
Wonderful. Thank you, Nils. All right. So we will take questions in the room as well as online. Feel free to line up, and we'll start right there.
So your example of the key HSM as a key manager for ACD drives, for example, self-encrypting drives, which encrypt data using a symmetric key from an HSM, and they are existing systems today, right? In the enterprise market, in financial institutions, in school districts, in hospitals, they're all using that today with today's HSM. What is the plan to migrate the HSM to a PQC capable HSM, but still support the keys that are used to store data and will be stored for a long time to come?
Let me perhaps first say, and I don't know if I got the question right or not, but so what you saw here is that these initial keys would come from the HSM, the initial keys that are protecting the profile that is then used for all these encryptions on the client itself in this specific example. The HSM itself would have the capabilities to have a PQ algorithm supported, but the system itself, the file and folder encryption, was a system or is a system that doesn't fully support that. That's just still using RSA. In the coming months, you will see that there will also be PQ support available, and then basically what you see today is asymmetric cryptography as RSA changing to PQ.
But then the key store, which still was just a key, right? It was key used for the purpose of media encryption with as a symmetric key. That key store would migrate into the PQC capable HSM at some point.
So what you saw also here is the symmetric keys would remain, and then only those keys that are protecting the profiles and the integrity of the profile itself, they would change, and the keys that you used before would not be relevant anymore because you would just be using the new keys, and the new keys would be used to unlock your profile and to use the existing symmetric keys that you
Okay.
have.
Okay. Good. Thanks.
All right.
Oh, you don't have a microphone.
Hello? Okay. A very point question. You have a nice protocol for secure distributing stateful hash-based signature key, state. Has any other HSM vendor signed on to that?
So that's a discussion that we have right now, also with NIST. We actually want that to be a little bit more of an open approach. So we don't want this necessarily to be just a Notimaco approach. That discussion is ongoing.
Thank you.
You're welcome.
Thank you. And we do have some online questions that we'll get to now.
Yeah, in somewhat the same vein, here's one question. According to FIPS 140-3, LMS cannot have any backups. Do you recommend using LMS if being FIPS compliant is important?
That's a tough question. I guess at a point that that was a rule, I believe there is a possibility that will also change as a requirement. Yeah. So I believe in the way it was in the beginning, it was not really usable. Now with the ways that the industry finds to still protect it and making sure that keys are only used once, I believe that requirement will also change.
And a follow-up to that is, how do you manage the backup challenge? Any workarounds?
Well, I mean, if you were using something like we implemented here, where the HSMs are actually handling that among each other in this trust relationship, then in that case you would find a way not to reuse keys. And if at the worst case, you would lose a certain chunk of your tree key, but not too much. So you would not jeopardize your whole tree that you have built up for your LMS operations, but only part of that. And that's actually exactly addressing this problem. But we need to have an industry discussion on that.
Last question online. What approach do you see being used to address the fact that there is a large stack of hardware, firmware, software dependencies, and vendors will be migrating at different times and supporting different mixes of algorithms? Examples, pure PQC, pure MLDCA, composites, etc.
I mean, in the end of the day, you mean vendors or customers using different algorithms?
Vendors themselves will be migrating pieces of their technology stacks.
I mean, the interesting thing about PQC is that the algorithms have certain characteristics, right? And some algorithms are better for one use case, and other algorithms are better for another use case. And with that, I believe we have to take or make some choices which algorithms are the best to support. So how do I replace an RSA algorithm with a PQ-safe algorithm for encryption? It may be a different thing than what I would do for my firmware signing. So I actually value that we have options, and I don't think it should be a big problem to support multiple ones. And that's the same on the customer side. We make these algorithms available, and hopefully customers are using that. The interface is roughly the same, and I mean the customer has a choice, right? And to choose the right one or the perfect fitting one for their own purposes.
Thank you.
All right, one more question in room.
I actually have two. So one would be the follow-up to the previous one. So like first thing, like I think running in a FIPS mode is one thing that customers are curious about. So giving the option of these available algorithms is good, but not all the algorithms are FIPS compliant. So how do we make sure we could leverage all of these, but also run in FIPS mode? Is there a way that we could do?
We have customers today that are looking differently at the FIPS mode itself. So we have some customers running in FIPS mode, some don't. And FIPS actually restricts some of that today. But again, I believe that there will probably be others, or, certain things accepted going forward.
Yeah, so in the roadmap, can we have a single instance, but have them run in both FIPS and non-FIPS mode?
At the same time on the same device?
Yeah, are there any, because that's the challenge.
It's a difficult question. I mean, today we have containerized HSMs, and theoretically you could have one container that runs in FIPS mode and another container that doesn't run in FIPS mode. I mean, this is possible. Now, if that fulfills your use case, or if certain other things are restricted with that, that's a little bit of a different question. It depends a little bit on your use case. Would be interesting to understand after that what you want to achieve with that. But generally, from how we set up these devices, it would be possible.
Awesome. Yeah. Yeah. Regarding infra-cross, but a separate question regarding the key management stuff that we went over. So one was like, even though the key management solution does support his PQ compliant, but they are almost supporting all the HSM towards the backend to be like FIPS level 3. But the wrapper key or whatever we call the KEK or DEK, this I don't see that being PQ compliant. That wrap. So ultimately, do we call the key management solution to be PQ compliant, or are we just ticking the box, or is it?
Are you talking more about the keys that key management system is storing and
So
providing?
key management system is storing PQ compliant keys,
Yeah.
so that is good.
Yeah.
But the wrapper key behind that is safeguarding in the HSM, so I don't see that being PQ compliant. So I just wanted to get
this
some
is
insights.
probably an evolution that you will see that will also migrate over time. I mean, in the end, these systems have to be PQ safe, as well as the data, of course, the keys that they store inside.
All right, and that concludes questions. Thank you very much, Nils. Appreciate it.
Thank you.
All right. And as we speak, there's closing remarks downstairs, so we might be missing it, in which case I'd love to thank you all for attending in person, virtually, speakers, sponsors, presenters, everybody involved in pulling this together. And there is going to be refreshments and networking at Under the Oaks, which is the downstairs area where the vendor flags are. Thank you so much, everybody.